All right. Hello, everyone. Here's a GC 100 exercise 4 podcast tutorial. I'm your instructor and host, Dr. VG. All right. So we're going to be using these University of Nebraska Lincoln simulators this week. So here you can click and open the main page that contains many of their simulators. I'm just going to go back here. So that has others that you might want to play around with. I'll also, when I'm finished here, add the hyperlinks. You can click and view this video. All right, so for questions 1 through 6, we're going to use the seasons and the ecliptic simulator. And then for questions 7 through 11, we'll use this motions of the sun lab. You can find both of those here or directly click and they'll simply open here. So I'll close both of those. We have a fresh start and it should look something like this. I'm going to zoom out just a little bit. Let's see, there we go. And so now some features you can do. You can choose, here's the subsolar point. We can have it shown or not shown, so you can kind of see it show up and disappear. We can change the date. You're going to want to make sure that's always visible, as it's kind of useful to reference that subsolar point location. You can click and drag the date and you can see the Earth revolving around the sun. So we're largely going to focus on the solstice and equinox. So 21st of June, December 21st, September 21st, and March 21st. So you can drag and find those dates this way. And then we're going to explore different places on Earth on different days, specifically different solstices and equinox days. Here, see if I can get it over close enough. 21st. There we go. You can also click and drag this person, the stick figure, and you'll see that the latitude here changes north and south of the equator, which is pretty useful. So we can click and drag. We can go all the way up to Marquette, Michigan here, 46.5, close enough for now. Could go a little further, see if we can get it exactly. 46. Oh, I was so close. Well, there we go. And so you can see on December 21st in Marquette, Michigan, the location of the solar point is in fact located at the Tropic of Capricorn here. So what you're going to do is you're going to move the stick figure in Marquette, Michigan, or other locations, perhaps at the North Pole or the South Pole. You're going to change the dates, and we're going to think about sun altitude. And so let's go back somewhere kind of closest to Marquette, close enough right here, and then you would change it to a specific date. Let's see, June 21st or 20th. And then I'll largely have you record here the sun's altitude. So you can really kind of see the angle of incidence. So in the middle of the day, what is that angle as sun's altitude of sun's rays striking our surface at that latitude? So 36.5 north, you can see as it changes as you drag it to the north or to the south. So I think that's pretty good for questions 1 through 6. Again, you're simply going to drag this person to find different latitudes. You're going to change the date, and then you're going to collect observations of sun's altitude. And then also we can kind of think about where is it sunny? You can see the circle of illumination, and where is it dark? So some places, even on the North Pole, in the spring, summer, you have sunlight, but on the South Pole, it's pretty dark if you're standing there. All right, so now we'll kind of jump back. I think that does, so just follow through the questions number 1 through 6. Each one will have you a specific setup, kind of like bring the observer's latitude to 90 degrees, change the date to such and such date. So just make sure to click through and follow along to answer questions 1 through 6. A brief demonstration here of the motions of the sun. So for questions 7 through 11, you're going to want to open this motions of the sun lab. Similarly, we're going to kind of change time and date and latitude, and you're going to observe. And now you can kind of see what this looks like. Here's your person. Here's the sun's path. You can do some animations where it's essentially kind of showing the path of the sun during the day as it comes up, as it reaches peak overhead and then down. And you can start and stop that animation as you so choose. For us, another thing you can do, you can actually kind of just drag this. You can drag everything around to kind of think about its highest point. Largely to complete question 7 through 11, you can simply change again. So if you want to do 46.5 here, you can even just type it right in. There's 46.5, or you can adjust this and try to drag it to its correct location. So 46.5. And then I'll have you change it to maybe like 1207. I'm going to change it to 1007 just for good measure. But you can change the time too by simply clicking and highlighting and pushing enter, and then it'll change. Or you can use this to change your time, which is kind of maybe tedious if you have to go too far. But again, you could change that to 12, for example. And then certain days you can drag this way to find your days like June 21st or December 21st, or if it's not quite there, you can change it here to December 21st and it'll automatically go. So things that we're going to largely look at here are sun's altitude, and then perhaps if it's above the horizon or not. So in some locations, maybe like the North Pole in the winter, the sun's actually below the horizon, in which case you would have a negative sun altitude, meaning the sun is literally below the horizon, or other times a year, here the sun is higher. So simply change, you can use this to click and drag. You can change the observer's latitude directly, change the time as specified, and change the date to follow through and observe your sun's altitude at different locations on planet Earth. So with that, Dr. BG is signing off.